In this video, I can show you what is photosynthesis, linear electron flow, and cyclic electron flow. Before we proceed to our main topic, what is photosynthesis? Photosynthesis is the process that converts solar energy into chemical energy. Directly or indirectly, photosynthesis nourishes almost the entire living world. The two stages of photosynthesis. Photosynthesis consists of the light reactions, the photo part, and the Calvin cycle, the synthesis part. The light reactions happens in the thylakoids. It splits water, release oxygen, reduce NADP plus to NADPH, and generate ATP from ADP by photophosphorylation. Linear electron flow. During the light reaction, there are two possible routes for electron flow, cyclic and linear. Linear electron flow is the primary pathway that involves both photosystems and produces ATP and NADPH using light energy. So, the first thing that's gonna happen is we're gonna have a photon of light that will comment and will excite one of the electron in a chlorophyll molecule in a light harvesting complex of photosystem 2. So when that happens, the electron goes up to the excited states and then falls right down to the ground and stays the electron in a nearby chlorophyll. Atom will get excited the excited states. So by doing that and able to pass along this energy through all of these chlorophyll molecules and then eventually pass into P680 chlorophyll A molecules in the reaction center complex. So when that happens, the one of the electron will get excited and picked up by the primary electron acceptor. But now we have this hole on this P680 molecules that needs to be filled by electron. So we're gonna come from the splitting of water. The chloroplast will gonna split water. So when it do that, it frees up this electron that can be then used to replace the electron that will just wax in P680 chlorophyll molecules. And so additionally, when the half-it is free the persons that will gonna pop in thylakoid space. In this primary electron acceptor, the electrons are going to move into small transport chain. So the first molecule that will gonna go to plastoquinone. So from plastoquinone, it will go to cytochrome complex. And from cytochrome complex, it will go to plastocyanine. And so we're gonna suffer there for a second. And we'll go to photosystem 1. So the photosystem 1 will have a very similar process happening. So we have a photon of light that hit one of its chlorophyll molecule and excites electrons and then pass through other chlorophyll molecule before goes piece of 100 chlorophyll molecules and the reaction center complex. So again, electron will get excited and picked up by the primary electron acceptor. In photosystem 2, we had splitting water to fill the whole well in photosystem 1. We used the transport chain in plastocyanine to fill the hole, so that is really how the electron move from photosystem 2 to photosystem 1. Through this connection with the piece of 100 chlorophyll A molecules. So now, the excited electron in the primary electron acceptor is gonna be passed onto another electron transport chain. So first molecule will go to ferredoxine, and then from there, it will go to NADP plus reductase. And from this, it uses electron to reduce NADP plus to NADPH. And then from NADPH, will go to Calvin cycle to complete the process of photosynthesis. And that is the linear electron flow. Now, cyclic electron flow. Cyclic electron flow uses only photosystem 1 and produces ATP but not NADPH. No oxygen is released. Cyclic electron flow generates surplus ATP, satisfying the higher demand in the Calvin cycle. So, cyclic electron flow is the path of electron flow in photosynthesis that involves only one photosystem, the photosystem. So that means we're not gonna be producing any oxygen because we're not gonna need to split water to resupply the chlorophyll and photosystem. So what's gonna happen with cyclic electron flow? So it will have a photon of light comes in and excites in chlorophyll molecules, and that excitement will pass on in the chlorophyll molecules in the reaction center complex. The electron gets excited and picked up by the primary electron acceptor. And so now it will be passed still in ferredoxin. But ferredoxin, instead of going to NADP plus reductase, it's gonna go to cytochrome complex. So that means we're not gonna produce NADPH and sending anything to the Calvin cycle. So from the cytochrome complex, it will go to plastocyanide and will go back into piece of 100 chlorophyll molecule in a reaction center complex and go again in a primary electron acceptor. So we can kind of see why it is called cyclic electron flow, because it is forming alternative cycle. And so even though it's not sent to Calvin cycle and it's not releasing oxygen from splitting water, they're still able to produce ATP using this electron transportation chain. And that's the cyclic electron flow.